So what I'll do today, just to set the context a bit, is I'll talk about the technologies. It's interesting, it ties right into sort of virtualization stuff, so I'll give you a bit of an overview on that. But then I'll jump very quickly into actually demoing how something like this works on AWS, full speed. So no emulation, no QEMU, nothing. How we can get Android to run on full speed on Amazon, for example, or Google Compute Engine, pretty much any cloud. And then I'll talk a little bit about the 3 use cases that we're seeing. Some people actually, there's a social networking company which is based pretty close to here that's already using us for some different use cases around Android. So I wanted to share some of that, but also get some feedback from you as to what else would you like to see? What else could be possible here? So let's get started. I'll give you a bit of background on virtualization first. So if you focus on how things have evolved, on the left you'll see what we used to all do 20 years ago, 15 years ago. You have an x86 server or a desktop for that matter. You run an operating system on it. That operating system runs one application typically, and that's it. That was the computing paradigm. Then of course, VMware came around and developed what we call a hypervisor. It ran on the physical server or a desktop, and it would allow you to run multiple virtual machines on top of that. That was the principle of virtualization. Lots of benefits in the data center server-side stuff, but you've probably seen a lot of that even in the desktop too. VirtualBox is an example of a hypervisor. VMware Workstation is an example of a hypervisor. Things like that. Those are typically type 2 hypervisors. You need an operating system to run hypervisor on top. So a little bit of complication around that, but in general, you've probably experienced a lot of this before with, as I said, VirtualBox or VMware Workstation or what have you. And you can run, as you know, Android and other operating systems as guests running on top of that VirtualBox stuff. Now, what we've done is, because Amazon, from an infrastructure perspective, runs on Zen, and so a certain type of virtualization technology that was open source a long time ago, and they had a lot of complications at that time around virtualization of the kernel or full virtualization with some work that Intel had done with VT technology done in the hardware, things like that. So we have a bunch of different flavors of types of operating systems that are running on Amazon, which is why it's not very easy for them to run Android on Amazon natively. That's kind of the thing. So what we've done for some of the other server end stuff that we were talking about is we've developed a new hypervisor, something that's called HVX, that allows you to run any virtual machine on any cloud without making any changes at all. Okay, so the idea is that if you kind of break down the stack a bit more into the kernel level stuff, you'll see that you get a VM from Amazon, you can run this particular hypervisor on it, and then you can run any virtual machine on top of that. A VMware virtual machine, for example, that's doing Android is one example. Okay, so that's kind of the point. It's built with certain technologies which you might be familiar with, binary translation and other things. You can run 32-bit, 64-bit, guest operating systems on it, stuff like that. So that's the idea. Net is you can now run essentially an Android VM on top of Amazon or Google Compute Cloud. Now, there are some challenges with it today. As I said, this is not our core business. We're not focused on it. The reason I'm here is to try to collect some input from you guys as to whether some of this might be interesting or not. So if you spin up an Android VM on Ravello, which I'll show you now, there are some challenges. The screen and mouse don't work that well. It's got to do with the PNC issue on how we connect to it. And most Android images these days are x86 images are built for VirtualBox. So our hypervisor actually exposes VMware devices up to the virtual machine, not VirtualBox devices yet. That's why the mouse is a little bit off, the screen's a little bit off. But the core stuff runs at full speed on Amazon. I'll show you that right now. We are going to, depending on sort of the market studies that we're doing right now, the assessment we're doing around whether it makes sense to even do this. Are there some interesting use cases out there? Is there something here? Then we can very easily add VirtualBox devices to our hypervisor. So that will expose now, proper mouse, proper screen, different display sizes, things like that for your Android virtual machine. So it's possible. We can do it. We'll know more in a few weeks. But in the meantime, I'll show you a demo of what's already working. And actually, full speed Android running on AWS as an example. You can spin up as many copies as you want. And the kind of things that some of these companies that have approached us are trying to do with it. One or two of the use cases that I'll tell you about are already in production, but they're actually using it. And others are just sort of brainstorming stages right now. So let's do this. Before I talk about the use cases, let us go ahead and do a real quick demo for you. Okay, so as I mentioned, the technology we've developed here is this nested hypervisor, but we're not selling it as software, we've actually productized it as a service. So if you go to the Ravello website, this is what you'll see. You can obviously log in, and I'm going to do that with my demo account here. And when you do, it'll open up an interface that's designed primarily for server-side stuff. Apologies, the UI looks like it's from the 1980s. We're going through a refresh here right now. But this is what you get, sort of like applications. Generally, this would be for backend developers to create copies, entire copies of their application environment, their backend environments to spin out, because the moment somebody checks the code, you automatically spin out a full instance of your production backend environment and run tests on that. So you're always testing on a director of production, things like that. So that's what is the list of applications here. But I'm going to click on this one, which we've done, which is a full stack application environment. So we basically just took this course, which is one of your publicly available open source collaboration tools, and we built a backend for that based on a standard web server, a real app server, and a database, and basically a cache, and that's it. Okay. And we've connected to it. You can see here two Android VMs. One's an ice cream sandwich instance, and another's a KitKat instance. This is a public example. And the idea here is the way you would get your virtual machines into this is you basically upload the VMware virtual machine, and that's it. You don't do anything else. You just upload the VM, drag it on, hit publish, and you're done. So that's through the UI. Also, you have full programmatic interface as well with our API. But if I click on this VM, you'll see that it's now running in Amazon. It's published in Amazon, Virginia. And at the bottom right here is my public DNS name. Okay? So I'm just going to copy that now, and I'll show you that you can actually connect it. But before I even open a terminal to it, let me open the console that you'll see here. This is going to open up an Android instance, so it runs. This is an actual Android instance running on Amazon. The really interesting thing about it is that there is absolutely no emulation involved. The execution of this is directly on Amazon's servers. That's kind of the way the instruction sets pass through directly to the hardware. So you get full speed with this. There's no emulation going on here. Okay? And when I said the mouse was bad, I wasn't kidding. It's really a little ugly here. But you can sort of get an idea of what it looks like with this. We're obviously fixing this, you'll see it. But what's more interesting than the console, I think, is if I just kind of show it to you. I'm going to get my DNS name here, and I'm just going to go in.
It's kill dash server, no space.
Oh, it's already connected, sorry. All right. And so you can see here, it says Linux localhost 3.036, Android x86. So this is what's running. I connected to the SRV RAV cloud, which is our domain where we run our production stuff. So this is a VM that we've got from Amazon. We're running our hypervisor on it. We're running an Android VM on top of that, and you're connecting it through an AV interface, basically 5.5. So that's just an example, just to show you that it's running, and you can check it out. We have a free trial and all of that, so you can go in and see. I'll tell you about that in a bit. But before I do that, let me just go back to the slides here and tell you a little bit about what one of the social networking companies that I mentioned is doing here. So they had a challenge here where they wanted to build what they call an end user experience monitoring system for their service that runs in the US. Okay? So they've got a data center in the US, they run the service out of that standard back-end architecture these days, hundreds of microservices and stuff that are running the data center. And they wanted to understand what their users around the world are experiencing with their application, okay? Or with their app or connected to that. So of course, one way to go is get a bunch of hosting facilities all over the world with their own infrastructure and do that. Or you can use Amazon. The problem is you can't run Android VMs on Amazon immediately. So they came to us and they asked us if we could help them out. And they're now running basically, I think there are about 9 regions around the world, everything from Sydney to Sao Paulo to Singapore and Tokyo and all these places. And what they've got, conceptually, they're doing a little bit more than this, but since we can't talk too much about it in detail, conceptually what it is in Ravello they have a Linux VM that's essentially a test driver, and it's running the test on an Android VM that's then hitting their backend. So they're studying the effects of latency and complex flows inside the application by hitting it out with real traffic from all around the world, and they're able to get a sense on how that application performs under these conditions. So real world sort of implications of that. So that's an interesting one. I'd love to get your thoughts on that. Another one is around continuous integration. I stole a diagram here from a really interesting blog that a gentleman at Etsy wrote, talking about their process, how they obviously maintain their code in GitHub. They're using Jenkins to schedule their tests and basically orchestrate everything. And they're on every commit, they're testing things on a farm of Mac Minis that they've got in their data center. And some of the stuff there is iOS, obviously, some of it is Android. And then they're using a service, AppTwag, and there are quite a few others that do the same thing for a different stage. But what if you could eliminate a decent portion of that Mac Mini farm that you have right now, basically the server farm that you have right now, for integration testing? So the moment somebody checks in code, you can now spin up, 100 instances, Android instances running in the cloud that all execute tests in parallel. Would that make things a lot easier? It could be, Android version this, Android version that, whatever. So you can have as many versions as you want running in parallel and multiple instances of those versions. So could that help? Now, obviously the downside here is that you don't have access to devices yet, like, a camera device or a gyro or, whatever else that the phone has. But from a core sort of operating system perspective, you're just testing functions of your code that don't belong, that don't interact with those devices. This might be a really interesting solution because you can spin up literally as many of them as you want, use it for running a test, use it for a few minutes, shut it down, and get done. That's it. You don't need to maintain any on-premise infrastructure, no hosting costs, no nothing. Just use cloud service to do that. So that's one other idea that people are talking a little bit about, but not really implemented yet. That's why I'm trying to get some input from you guys. And lastly, it's just a sort of a variation on that, which is scale testing. So you could potentially spin up, in fact, I got an inquiry the other day, somebody wanted to spin up 15,000 instances of Android to load a back-end application. We won't be able to scale immediately to that level, but with a few tweaks on our end for our back-end service, we could potentially do that as well. Would that help in any way? I don't know if you have some ideas from you guys. What would having Android instances running in the cloud, so many of them, generating, I guess, some more real traffic based on some complex flows? I was just talking to the gentleman here around, his company does an app around scheduling for small businesses, and they have some pretty complex flows that they like to test. Potentially something like that can be done here. Again, lots of traffic coming out here. How it would be different from a standard Linux server generating load, I don't know. But it could be an interesting use case there as well. So I'd love to hear from you guys around these 3 things that we talked about. Any sort of input that you guys have in either the end user experience monitoring or the continuous integration functional testing done in parallel, or potentially even the stateless stuff. I'd love to hear if there's anything you guys have. Any ideas? What would you like to see? What would make your life easier as an Android developer from a testing perspective? Anyway, we don't have to do it immediately here, but if somebody has some ideas, we're going to be around for a little bit. Come and talk to us. We'd be more than happy to understand some of your challenges and give you very honest feedback as to whether there's something we can look at or not.
So I have one question.
Sure.
I'm looking at multi-platform, so both Android and iOS.
Yeah.
So having the ability to do virtual Android, it seems fairly straight. It seems pretty reasonable.
Yeah.
Doing with iOS, wouldn't you have some licensing issues?
Oh, all kinds of licensing issues. That's what we're going to do. But yeah, I mean, it's this is an x86 machine, and we know how to virtualize that. There's no reason why we can't run OS X on AWS other than licensing issues. I mean, there are some affinity things with some devices and all of that as well. But you could address those. Just have it added into a queuing module and you're done. And it's easy. We know how to do that. So I'm pretty sure we can do it. It's basically licensing. That's really what it's all about.
How do those instances compare to real phones as far as speed and?
I think mine can be faster than a real phone. What's the processor on one of these cutting-edge devices these days?
Yeah, but, I mean, I guess when you're scaling or doing certain tests,
Yeah.
if you're trying to mimic a phone, I guess I'm wondering how well it would work.
Okay, let me give you an example of the stack. Okay, so Amazon has powerful machines.
Right.
Their virtual machines are also very powerful. They're designed around server workloads. So we take one of those VMs and run, say, for example, 4 vCPU server. When I say vCPU, because it's a virtual CPU to allocate to us. And 16 gigs of RAM. Okay, 32 gigs of RAM. Now I run a hypervisor on it, and I can run 10 Android instances on that. Each one of them is going to get a good chunk of the CPU, which may be more powerful than some of the phones that are there right now. And they all get 3 gigs of RAM every potentially to 5. You can test it out. They have a 14-day free trial. I'll get an Android, you can transfer it to your account. You spin it up and run a test on it. I'd love it.
Right, but what if you want to try and mimic the phone to make each instance as realistic as you can to a real phone?
So right now what we've got is we're not changing Android in any way. It's the stock Android. We found somebody who compiled it for I think VMware or some platform. We just took that and we ran it. That's it. So if there's any modifications you've done and you want to test that, sure. That's the point. It's full virtualization. So even if you're an Android kernel developer and you want to test kernel patches of Android, you can use that. So certainly the app stuff, it's stock Android. There's no
I understand. I'm just thinking of mimicking the hardware of the phone.
Yeah,
How
the devices are
much
missing.
memory you have and things like that.
Absolutely. The devices are missing right now, right? That's the thing. But there are ways in which we can emulate those devices and add that in there as well. So if your app needs a camera and a gyro to do a particular flow for your functional test or system test, we can do that. So since this is not our primary market, we haven't done it yet, but there's nothing. It's totally well possible. But yeah, there are some specific things that I think stand out. One is we don't do iOS, we cannot do iOS. Consequently, that part's out. Today there are limitations that I mentioned on the device, the screen, you saw that, and the mouse, which are a little bit painful. So you would not use it to design tests on that VM, but you can use it to run and run fast and run in parallel. So that's the way to think about what's possible today. And then going forward, if there's an interesting, and by the way, the other thing you can do today is the stuff that like social media companies, global user monitoring thing, or stuff like that. And going forward, if there's something interesting, we're happy to put those devices in and make it a little more and more. Anyway, so yeah.
As an Android developer, I would love to see if be able to test the applications that you're developing on processing of Android devices that kind of what you were saying, the Android devices, but because the Android devices that really vary in display resolutions, Android versions, RAM capacity. So
Yeah.
just a easy way to be able to quickly test an app.
Yeah.
See what looks like and how it functions.
Okay, so let me show you how interesting. Some of that is doable here, but not with the devices that I mentioned. That's still the problem. But you could, so say for example, you come to Ravello and you say, I want to build a new application, and please let me know when I'm running over my time quota. I want to be mindful of the other speakers as well. But real quick here, so let's say this is an Android VM, okay? I drag one on, and I double click it, and I'm going to change this from one vCPU and 1 gig of memory to one vCPU and 2 gigs of memory, and I'm going to save that, okay? And then I'm going to drag another version of this on. Think of this as another instance of Android, whatever, different operating system, blah, blah, blah. And I go here and I say 1 and 1, that's okay. So I can basically drag and drop, let's say, 50 of them or 100 of them on this concept that we call an application. So this whole thing is an application alone. So you drag out all of your Android VMs onto that, and you hit publish. All of a sudden now they're all running in Amazon. Each one of them have a publicly accessible DNS name. So you can automate those custom moments on each exit code. You're running it against all those configurations. Now again, what's missing is the devices. Got that part, but that's clear. But in terms of being able to have easy access to all of these instances running parallel of different sizes, different OS, versions, if you will, that's possible today. But I'm not clear on the device. What about the experience monitoring thing around the world? You guys see something like that? An interesting use case there. Because from what I understand, this guy that I was talking to, guys using stuff, was telling me that they've uncovered some really thorny bugs in the first 2 weeks of implementation purely because of the data solutions. So when new conflicts flows with these, especially with variable latency from around the world, you do see some funky stuff both on the app side as well as on the back end side, and help them, get the root causes on that. Have you guys seen some of those things? You have those kind of experiences as well? Okay, anyway, it comes to you. But we're around, so thank you for your time. And I'm around here in case you have questions or you'd like to dive a little bit more into Linux kernel virtualization, because there's nothing more fun than that.